The introductory 1D motion physics equations would be this first one, v equals d over t. This you can use when you have a constant velocity or an average velocity. So for example, you traveled a certain distance and took so much time to do it, you could calculate your velocity, even though there might have been acceleration, deceleration going on, but you kind of came up with what your average velocity was. That would be used, or if it never changed, you'd use that as well. This equation right here, v average equals vi plus vf over 2. This would be used in two scenarios, average velocity with a constant acceleration or two equal intervals. So for example, if you went from 0 to 60 miles per hour, then your average would have been cut down the middle, 0 plus 60 divided by 2, and you'd get 30. You could use it there. Or if you traveled one leg of a trip, 1 hour of a trip at 60 miles per hour, and the second hour of the trip at 70 miles per hour, you could just pretty much add the two together, divide it by 2. That's when you'd use that equation. And then the acceleration equations, they're all unique. There's 5 possible variables that you'll find in these equations: d, t, vf, a, and vi. And so based on what you have in a givens list and what you're trying to solve for and what you don't even care about, you can pick between these 4 equations. And as long as you have 3 things you know and 1 thing you are looking for, you could pick one of these to solve most any acceleration physics question. So let's take a look at that in use. You have an example here. A LaFerrari can go 0 to 60 miles per hour in 2.4 seconds. What is its acceleration? Well, you have 0, VF is 60, the time is 2.4. What's its acceleration? You're solving for A. So we know we're going to be using a constant acceleration equation right here. And we have VI, VF, T, and A. We don't have D. And if you look up here, VF, VI, A, and T, no D. This is going to be the equation we use. And so that's kind of how you pick it out. Let's look at another example of when you wouldn't be acceleration. A Ferrari has a top speed of 217 miles per hour. At that rate, how long would it take to travel the 69 miles from Midtown to Athens? Well, you have V, D, T. It never said anything about going faster or slower. If you were going that rate, one single rate, well, in that case, you'd use the constant velocity equation up here. Now, one thing I do have to note, going back to the first example, miles per hour and seconds, they conflict with each other, so I would have to convert one to the other. I'd have to either convert this to miles per second or the seconds to hours. And unless the question told me otherwise, I'd probably go to the SI unit of seconds.